Hello everyone, welcome to today's webinar. Today we will concentrate on fractions. Fractions is the most challenging units that I find students having trouble with. So we dedicated today's webinar to go over the most challenging topics within that lesson. Today also we will look at how to study for the lesson. Before we start our math part of the webinar, I'd like to introduce myself. My name is Miriam. I'm the math instructor at Penn Foster. I am here at Penn Foster since October 2015. I'm certified to teach high school math in the state of Pennsylvania, and also I have a master's degree in urban education, and I did earn that 2017. Today's webinar's objectives is basically how can we study for this lesson or generally any math lesson. This is the most question I get over the phone or over emails. How can we study? With the subject that has lots of text, students are more used to how to take notes, how to study, but when it comes to math, it's a little bit confusing for them. We will go over some practice problems, and also I'll give you the chance to practice as well. Let's start with note taking. Whenever you study for any subject, whether it's a high school course or a college course or a training through your job, you need to note take. You need to learn how to note take so you are taking away the most important points from a lecture, from a written lesson, from a webinar, and so on. So how would you study for a math lesson? The first thing I find useful is to thoughtfully read the lesson. So we have to read. We need to read text to be able to learn information. It's not the only way available, but it is one of the important ways that we read. And we read in a quiet place. We read in a comfortable place. We concentrate while reading. We do not have loud music, people around us while reading that math lesson. We really need to, when we read, we need to have some comprehension going on whenever we read the lesson. Another point I find important whenever you're trying to note take, whenever you're studying for a math lesson, is to take notice of the important points that you find while you're reading. So you're reading a 3-page lesson, for example. That lesson that has 3 pages maybe has 3 or 4 main ideas, no more. So you need to make sure to point at those important points. With math, usually they are formulas, important examples, for example, sometimes definitions of keywords, sometimes shapes or figures that you need to keep in your notebook as your notes to refer to later in the exam. All of these need to be on your notebook. Another third point whenever you are trying to note take is to summarize what you read. I've talked to a lot of students who basically rewrite everything they read in the lesson word for word. And that's not note taking, that's basically copying whatever you read. So the point of note taking is to read the lesson, comprehend it, and then write it again in your own words, in your own understanding. So that is a key point on note taking. It works for any subject, and also it works for math. Another point I find so important is to keep your notes appealing. So you can use arrows, you can use abbreviation just to keep everything short, charts, flow charts, diagrams. You can use colors, highlighters, pens, pencils, stickers, whatever makes your notes neat, easy to understand when you go back to it to prepare for the exam, and it has everything you need from that lesson. In this slide, I brought a section from the reading from the lesson of fractions, and I just wanted to show you how would I take notes from that section. So this section is talking about how to add and subtract unlike fractions. So when I'm taking notes, I'm gonna make note of the title itself. It says unlike fractions. That means that there are like fractions and unlike fractions. So I decide to write down that flow chart, reminding myself that fractions have two kind of them based on the denominator, so like or unlike. And again, I put the definition. What is a like fraction? They have the same denominators. What are unlike fractions? They have different denominators. And then I go on and list the rules. The lesson itself has the rules listed for steps to add or subtract unlike fractions. I'm not going to go ahead and write down those steps word for word as it appears in the lesson, but instead I'm going to go ahead and summarize or put those steps in my own words based on my understanding or comprehension. I can use colors, I can use bubbles like here, I can circle things that are keywords like the LCD, the least common denominator, is a keyword in this lesson, I think. And so on. So this part of my notes did summarize main ideas, did order the steps I need to take in my own words. It looks appealing to me, and I'm willing to use again whenever I'm taking my exam or preparing for my exam. Next, how can we practice for math? So I speak to lots of students and they say, I did watch a ton of videos and I still do not get it. What should I do? I always say that resources, whether they are readings or recorded lectures from your lesson or recorded videos from awesome teachers that they post their, their lectures on YouTube or any other kind of site is useful, and definitely look for them, use them. You don't have to use everything out there, but definitely pick the best that you think is useful, and for sure use the lesson and the practice. Now, it's not sufficient for anyone to learn math by just watching a video. If I watch someone that add those two fractions together, it's not enough for me to learn how I can do it myself. So the key point here is to practice, and practice as much as you can. Within your lesson, there are discover more questions provided, and they are relevant to the lesson, relevant to the exam. Take your time, open up a notebook, and write down the question clearly, practice and practice. And when you submit your answers through the Discover More box in your portal, you are provided with the answer key. Then you can compare the answer key with what you've got. If they are matching, then you're done. You're good in that concept. If not, then try it again and try to find out where you've messed up. And this is how we learn. When you are beginning to learn math, it is always a good habit to do your work once and then repeat it again, just to make sure you subtracted correctly. You did find the right LCD. By doing this and by time, you do not need then to check your answers anymore. You're just going to be able to find the right answer from the first time. But as a beginner, I recommend that you repeat the steps again. And if you find that your answer, the first answer, is the same as your second answer, that is a confirmation that you did everything correctly and probably your answer is correct. If you got some of the answers incorrect, do not get discouraged. We all fail sometimes, and this is how we learn to improve. So if you did a question, you did compare your answer with the answer key, it turned out to be incorrect, do not give up. You just want to go back and see where you have added incorrectly. Where did you miss write a number here or there? Did you treat an addition like subtraction? And once you know where you usually miss up, this is when you're going to remember it and probably you're going to avoid that mistake again. My last advice to you is to be patient on yourself. Learning any new skill takes time, takes patience, takes practice. Think about learning how to drive a car. Think about how you, if you decided to learn a new language, how much time and practice it will take you. Even if you get a new job, how much effort and time and practice it takes you to get used to the new tasks in your new job. So be patient on yourself, use the resources, practice and practice and practice. And at the end, if you need help, we're here for you. Next, let's do some math. So let's practice some of the problems from some of the topics in that lesson that students have questions on when I get to talk to them or email them. One of the topics that students mostly call about is how to add unlike fractions. We just learned that unlike fractions are two fractions with different denominators. So if you look at the problem, you have two mixed numbers. One denominator is 3 and one is 7. That means that these fractions are unlike fractions. That means we are not able to add 1 plus 4 is 5 and 3 plus 7 is 10. We cannot do that. We have to find the LCD, the least common denominator. And we do that by listing the multiples of 3 and the multiples of 7. Whatever number comes first to be common between the two lists, that would be the new denominator that you're going to use. By practice, you will notice and you will identify the LCD without having to list all the multiples of both denominators. So if we multiply 3 times 7, we have to do the same thing on the top, 1 times 7. That would make the denominator here 21. If you do the same thing here but multiply times 3 to make the denominator 21, so 3 times 7 is 21, 7 times 3 is 21, and that's what we want. Now multiply times 3 on the top. Remember, whenever you multiply a denominator times a factor, you have to do exactly the same thing on the top, and that's why we multiply times 3 and multiply times 7 here. Now, remember that we are not going to multiply the 7 or the 3 times the 1 or the 3. The 1 and the 3 are whole numbers. They are not part of the fraction. They are part of the mixed number, but it's not part of the numerator or the denominator. So our new problem will be rewritten as 1 and 7 over 21 plus, we're adding 3 is the same. 4 times 3 is 12, and 7 times 3 is 21. We now are having two denominators. They are the same denominators. In this case, we're just going to go ahead and add the whole numbers and add the numerators and then keep the denominator as is. 1 plus 3 is 4. 7 plus 12 is 19, and the denominator stays the same. And that would be your final answer. Now, in those bubbles in my slides, I did list the order of the steps that we need to take to perform the operation with the set of fractions or mixed numbers that we have in each slide. So if you want to borrow these and write them down in your notes, you're welcome to do so. This is a self-check. I did mention in the beginning of the webinar that we will practice some of the problems. So if you are watching this webinar as a recording, I would advise that you pause the webinar, do the problems yourself, and then replay it again so you know the right answer. So again, we're adding 3/10 plus 5 and 3 over 5. What should we do? We have different denominators. They are unlike fractions, and we are trying to add. what LCD or the least common denominator that we need to use in order to perform the addition operation. I'm just allowing some time for everyone to do the problem. Whenever you are doing any math problem, I recommend that you have a notebook, you have a good writing utensil, you write your problem clearly. So the 3/10 should look like a 3/10, not a 3/1. The fraction sign is so obvious to you when you write it. The plus sign is a plus sign, not a minus sign, and so on. So whenever your brain is working with the problem, looking at the problem in your page, everything is clear. So your brain is able to then apply the rules of adding unlike fractions. Let's do the questions together again. 10 and 5, by practicing, I realized that 10 is a multiple of 5. So that means if I multiply 5 times 2 and 3 times 2, that will make the second fraction having a 10 in the denominator, which is the same as the denominator in the first fraction. So actually, I do not need to change the first fraction at all. So we are able to rewrite our problem as 3/10 unchanged plus 5. We're not going to multiply that times 2. 3 times 2 is 6. That would be the new numerator. 5 times 2 is 10. Now we are able to perform the addition since we have common denominator. Now add. Nothing plus 5 is 5. 3 and 6 is 9, and 10 will remain the same in the denominator. Then the only right answer in this question is B. B is the right answer. Let's move on to the next topic that I decided to bring in this webinar. Subtraction. Again, we're subtracting unlike fractions. Subtraction sometimes is tricky because some of the cases that we will see later on in this slide, we have to borrow. We need to know when we decide to borrow and how can we borrow. But not every single subtraction problem you need to borrow. We need just to borrow whenever we need to, not always. So let's look at the first question. 5 and 6/5 minus 1 and 1/3. Again, we need to find a common denominator. We have a 5 and 3. 5 is not a multiple of 3. 3 is not a multiple of 5. Then I know we have to change both denominators. I'm going to do that by multiplying the first denominator times 3 to get 15. Do the same thing with the top. Do not change the 5. And then 3 times 5 will give you 15, and times 5 on the top to keep the fraction the same. Rewrite the problem. We have 5. 6 times 3 is 18 over 15. That's the new denominator. Minus 1 unchanged. 1 times 5 on the top is 5 over 15. Now we'll try to subtract. To decide if we have to borrow or no, after finishing up changing both fractions to like fractions, which we did, we have now 15 in each denominator, we look at the numerator. If the numerator 18 is greater than 5, which it is greater than, we do not need to borrow. We just gotta go ahead and subtract. If the first numerator happens to be lower than the second, then we have to borrow. 5 minus 1 is 4. 15 will stay as is in the denominator. 18 minus 5 is 13. And this is your final answer. Let's look at the second problem. Again, we're subtracting unlike fractions. What should we do? First step, I'm not going to judge. yet if we have to borrow or no, unless we do change the denominators first to like denominators or like fractions. I know that 20 is a multiple of 4. Then 20 will not change. This fraction will not change. The second fraction will change. Times 5 to make it 20 and times 5. Now rewrite the problem. 6 and 11 over 20 unchanged minus 15 over 20. Now we have like fractions. What should we do? Let's attempt to subtract 11 minus 15. Well, 11 is smaller than 15, so this problem asks us to borrow. How can we borrow? We have to borrow a whole number 1 from the 6. We have 6 whole number in the first fraction. I'm going to borrow 1 of those 6. So I'm going to change the color just to explain more what to do. I'm going to make the 6 5 because that 6 is going to give me 1. So the 6 will become a 5, go down by 1. Now, the 1 I borrowed, I am able to write it down in a form of a fraction. 20 over 20 is a 1. This is the 1 I borrowed from the 6. I have to add this to the original fraction in the first mixed number. So add it to 11 over 20. This here in red is the first mixed number after we borrowed the 1 from the 6. We still subtracting minus 15 over 20. Let's simplify those two fractions. Again, the 20 over 20 is basically 1. We did borrow that 1 from 6, so we're able later on to perform the subtraction. Now we have the 5. These two fractions are added. They are like fractions. 20 will be on the denominator. 20 and 11, it's going to give you 31. I'm still subtracting minus. The second fraction is 15 over 20. Let's now attempt to subtract the numerator. Would it work or no? Well, 31 minus 15, yes, it would work. And that is 16. 20 will stay in the denominator. 5 minus nothing is 5. I'm able to simplify this fraction further because I see a common factor between 16 and 20. Both of them are even numbers. Then I can just divide over 2 and divide over, or I can divide over 4 actually. That would be easier, and divide over 4. So the answer now would be 5. 16 over 4 is a 4. 20 over 4 is a 5. And this is the final answer in simplified form. Let's look at a self-check, a practice for you. Get your paper, write down the problem. After you write down the problem, inspect the denominators. Do we have to find a least common denominator or no? And if we do, how can we rewrite this fraction or this problem? Do we have to change the first fraction as well, or just the second fraction? All of these questions will come to your mind as you practice. They come faster. You don't have to even think about asking yourself the question. It will just come automatically. You just need to practice and practice. I'm going to leave you to try this problem and come back. Okay, let's try the problem together. So I noticed that 15 is a multiple of 3. That means that I don't have to change both fractions. I'm able to change one fraction. I'm going to multiply 3 times 5 and times 5. Rewrite the problem. We have 7, 4 over 15. That's unchanged. Minus 1 is the same. And then 1 times 5 is 5. And 3 times 5 is 15. We have two 15s in the denominators. Now we need to decide. Do we have to borrow or no? 4 minus 5, 4 is less than 5. Yes, we have to borrow. How can we borrow? I'm going to borrow 1 from the 7 and add it on to this fraction. Let's do that together. So that 7 will become 6. That 1 I'm able to represent in terms of fractions as 15 over 15. I still have to add that 1 I borrowed to the fraction plus 4 over 15. I'm done with the first mixed number. Let's finish up the problem. I'm still subtracting minus 1 and 5 over 15. Combine the two fractions in the first mixed number. We have a 6. 15 and 4 is 19. 15 is the same in the denominator. I'm still subtracting minus 1 and 5 over 15. Now let's check 19 minus 5. Yes, we can do that. So let's subtract. 6 minus 1 is a 5. 15 will remain the same in the denominator. 19 minus 5 on the top is 14. And this is the final answer. So the answer would be D. Those problems about borrowing whenever you have to subtract, not all problems I need to remind. Some problems we need to borrow, and sometimes we do not have to borrow. So these kind of problems are the most challenging problems in the lesson. If you do not know how to get the answer for the ones we did in the webinar, I recommend that you go over them again. You go over the problems that you have to borrow in from the Discover More questions until you master it. Okay, let's look at another problem, multiplication. The good thing about multiplication and division with fractions, we do not have to have the same denominators. So that makes it a little bit less stressful on us. How can we multiply two mixed numbers? I'm going to say what we should not do first, and then I'm going to go over what we should do. We should not multiply 2 times 1, 2 times 4, and 3 times 5. That is not correct. We have to change any mixed number to an improper fraction first before we multiply or divide. So we have two mixed numbers, change them to an improper fraction for each, and then we have to follow the next step. Let's do the changing first. How can we change a mixed number to an improper fraction? It's really straightforward. 2 times 3 is 6. 6 and 2 is 8. 8 would become the new numerator. Over 3 will stay as is. I'm done with the first mixed number. Let's do the second one. I'm still multiplying. 1 times 5 is 5 plus 4. That will give you a 9 on the top, and 5 will remain in the denominator. That's it. I'm done with the first step. And again, those rules, you can borrow and write them down in your notes if you'd like. Now, what's the next step? The next step is not to multiply across yet. We need to check if any of the numerators and denominators have anything in common so we can eliminate that. So that way, when we multiply, we do not have to simplify the final answer. I see a 9 and a 3. If you divide 3 over 3 and 9 over 3, your problem will become 8 over 1, 3 over 3 is a 1, times 9 over 3 is a 3 over 5. Now my problem became more simpler. Anything else is common? And the answer is no. At this point, then, we are able to multiply across. 8 times 3 is 24 over 5. This is your answer. Or if you want to change it to mixed number, then you can have 4 and 4 over 5. How did I do that? How many times 5 goes into 24? 4 times. Keep the 5 the same. Multiply 4 times 5 is 20. Subtract 24 minus 20, the product. That will give you the remainder 4. Later on, after we conclude the webinar, I'm going to send you the 3 full webinars that go step by step on simplifying fractions, changing mixed numbers to improper fractions, and vice versa, so you can practice more with these. Practice question. You can write down the problem. We have a mixed number times a fraction. Can we just go ahead and multiply, or we have to do a step to prepare our problem first and then do the second step? What do you think? Okay, let's do the problem together. If you're watching this webinar recorded, I recommend that you pause it, do the problem, and then watch how we find the answer. So a mixed number, and we have multiplication, we have to change it to an improper fraction. How do we do that? 2 times 8 is 16. 16 and 3 is 19 on the top, and then 8 on the denominator times. The second fraction is just a fraction, it's not a mixed number, then it will stay as is. Now we ask ourselves, are we able to eliminate any common factors between a numerator and a denominator? We can eliminate the 2 over 2 and over 2. You can do over 2 here and over 2, the 6 over 2, it's up to you. We'll give you the same answer. So let's rewrite the problem. 19 is as is. 8 over 2 is 4 times 1, because 2 over 2 is a 1, over 6. We are not able to cancel out the 2 from the 6 and the 4. Remember, when we do the cancellation method, we have to cancel out common factors from a number from the top with a number from the bottom. We cannot do 2 denominators or 2 numerators. At this point, we just go ahead and multiply across. 19 times 1 is 19, and 4 times 6 is 24, and this is the right answer. C is the correct answer. Next, another type of problems involving multiplication. We have a whole number in our problem and a mixed number. What should we do? Whenever you are using or dealing with fractions and you see a whole number, it is always a good idea to represent the whole number in terms of a fraction. How? Well, just rewrite it as 5 over 1, because 5 over 1 is basically 5. It just looks like a fraction, so it makes sense when we multiply it times another fraction. Times, this is a mixed number, we cannot keep it as is. We have to change to improper fraction. 1 times 30 is 30, plus 7 is 37 over 30. Let's see if we're able to eliminate anything. I see a 5 and 30. Yes, we can eliminate the 5, divide over 5 on the top and divide over 5 on the bottom. So we have 1 over 1 times 37 over 6. Nothing else to be eliminated. Then we are ready to multiply across. 1 times 37 is 37. 1 times 6 is 6, or you can write it in mixed number form, 6 and 1 6. Let's look at a practice and see how would you do multiply 6 times 7 and 1 6, a whole number times a mixed number. It's always good to change the 6 to a fraction form, which is easy. Just put a 1 on the denominator. Take just a few seconds and then we'll go over the problem together. Okay, so let's begin by changing 6 to simply 6 over 1 times. Now 7 times 6 is 42 plus 1 is 43. 6 will remain in the denominator. This is one of the steps we had to do to prepare the problem. Now I see 6 and 6, that's easy, over 6 and over 6. Then that would become 1 over 1, 6 over 6 is a 1, times 43 is the same, but 6 over 6 is a 1. Multiply across, really, it's going to be 43. It's a whole number. Some of the students asked me before in previous webinars and calls and communications, how come we multiply a fraction times a fraction, it gives us a whole number, or how come we add two fractions, it's a whole number answer? Well, if you do all the steps correctly, your arithmetics are good, right? Everything is true. And if you end up with a whole number answer, then this is your answer. And in this case, 43 is our answer. Division. Okay, when we divide, again, we do not need common denominators, but we have to do some steps again to prepare our problem. One of the steps that we have to do is, you can guess, change the mixed number to an improper fraction. 3 times 3 is 9, plus 2 is 11. 11, and 3 will remain in the denominator, divided by 3 over 5 is just a fraction. How can we divide then? 11 over 3 divided by 3 over 5. That's lots of divisions, because 11 is divided over 3, and then these divided by 3 divided by 5. Too much divisions. An easy way to do divisions when it comes to fractions is to use the reciprocal of the second fraction. What do I mean by that? I mean that you keep the first fraction as is, change division sign to multiplication sign, flip the second fraction, or write the reciprocal of the second fraction. It was a 3 over 5, make it 5 over 3. That's it. Now it looks like a multiplication problem like the ones we did in the previous slides. So use the cancellation method. 11 and 3, nothing common. 5 and 3, nothing. Then I'm ready actually to multiply across. 11 times 5 is 55. And 3 times 3 is 9. This is your final answer, or if you'd like to put it in mixed number form, it will be 6 and 1/9. So I just want to repeat the steps again. Change all mixed numbers to improper fractions. Change the problem to multiplication using the reciprocal of the second fraction, and just treat it as a multiplication problem. Let's do another one, which you get to practice. Similar, two mixed numbers, they are divided. What should we do? Take a few seconds, write down the problem. You don't have to make a decision or write anything before you think about it, and you have a logical reasons why you're doing those steps. If you do not find a reason from your lesson why you should do a certain step, then you should not do it. So take a look at the problem and start writing down your first step. What should we do? Okay, so the first step is change the mixed numbers to improper fractions. And so far, we know how to do that. 1 times 2 is 2, and 2 plus 1 is 3. So 3 over 2. We're still dividing. Divide. 2 times 6 is 12, and 12 plus 5 is 17, and 6 will remain in the denominator. Now we can change the problem to multiplication problem. So we do 3 over 2 times, flip the second fraction, 6 over 17. Look if you are able to eliminate any common factors. I see 6 and 2, so yes, over 2 and over 2. Rewrite the problem, 3 over 1 times 3 over 17. Nothing common between these numbers, then go ahead and multiply across. 3 times 3 is 9, and 1 times 17 is 17. This is your answer, and the answer is C. Now, what if we have a mixed number over a whole number? Again, nothing new. We change the mixed number to an improper fraction and change the whole number to a fraction form. This is all we have to do. So let's do step by step. Change the first mixed number to an improper fraction by multiplying. 3 times 8 is 24. 24 and 3 is 27. 8 will stay as is in the denominator. We're still dividing. We did not change the problem to multiplication yet. We have to be careful when to change the problem to multiplication. Now 3 is actually 3 over 1. Now, both of the operands, or both fractions, are actually in fraction form. No mixed numbers, no whole numbers. I am ready to go ahead and change the problem to multiplication. 27 over 8 will stay the same, times, flip the second fraction. It was a 3 over 1, make it 1 over 3. Now find any common factors you may find. I see 27 and 3. 27 is a multiple of 3, so over 3 and over 3. 27 over 3 is a 9. 8 is unchanged, times 1 over 1. Multiply across, your answer is 9 over 8, or if you want to put your answer in mixed number form, it's going to be 1 and 1/8. Next is a self-check question. Write down the problem as is. Make sure that you write everything clear in your paper. And then think about the second step, or the first step that you're going to take. What is the next step to prepare the problem to perform the division? Okay, let's do that together then. Well, 22 is a whole number. We're dealing with fractions, so I'm going to switch 22 to a fraction form. So I'm going to write it as 22 over 1. That's it. Divide. I'm not going to change anything to multiplication yet. Change the second fraction to an improper fraction. 1 times 6 is 6, plus 5 is 11 on the top and 6 on the bottom. Now, change the problem to multiplication using the reciprocal of the second fraction. So 22 over 1 will remain the same, times, flip the second fraction to 6 over 11. Now look at any common factors. I see 22 and 11. I know that 22 is a multiple of 11. I know the common factor then would be 11. Divide over 11 and divide over 11. 22 over 11 is a 2 over 1, times 6 is unchanged. 11 over 11 is, of course, 1. Multiply across 2 times 6 is 12. And, of course, 1 times 1 is a 1. Any number over 1 is itself. It's a whole number, 12. And, again, it's a whole number. The answer is A. Now, I have been asked the question before, how come when it asks us to divide, we multiply? Well, when you multiply times the reciprocal of the second fraction, it is equivalent to division. So it's just an easier way to divide. So when we multiply times the reciprocal, we're not multiplying actually, we're dividing. So I hope this point is clear and not causing any confusion. How would you prepare for the exam? You need to read your lessons. Nothing is easy. Nothing is straightforward that you just read the lesson, next day you get 100 in the exam. I mean, unless you have a background knowledge about fractions, that's something else. But if you still understanding fractions, it's your first time really to work in depth with fractions, I would recommend that you take your time, read your lessons, use your resources, take notes. Do not get discouraged. Do the practice questions. Spend your time because you really want good grades on your transcript. You want a good GPA. So when you apply for college or a career program, later on, your GPA is a good GPA that you have multiple chances to go different places, not limited to one or two places. The answer here again is provided for those discover more questions so you can self-assess yourself. You can watch this webinar again. I'm going to again send the 3 full webinars on this one unit through the message center, so keep an eye on your inbox. Take the exam only when you are ready. Only when you are ready. And if you happen to take the exam once and you did not do well as you expected for yourself, then restudy and retake the exam. Here's how you can reach out for help by phone. From 9 to 6, we're open. I leave the office at 5. So if you have a fractions question, it's preferred that you call or communicate with the school from 9 to 5 Eastern Time on weekdays. You can schedule an appointment through the calendar for math. I'm going to be able to send that to in the message center. If you do not have it, you can email your teacher, whether myself or your teacher that you deal with. How can you email your teacher? It's from the portal. You log into the portal. On the left-hand side, you see those gray tabs. One of them says help and support. You want to click on it. That will appear. You want to click on the search button first. You may have to do that first, and then when you do that, those 2 options will appear in that banner. If you want to send an email, you want to click on contact us. That will open up the email form that you see here. Write to your subject, the title of the email, the content, the question, be specific, which discover more question, which lesson, and so on, and just continue. If you want to do a live chat, you click on chat, and if you're clicking on that between 9 to 6, you will have someone to assist you. At the end, I'd love to hear your questions. If you have no questions now or you cannot think of any questions, you're still able to communicate to your teacher or to myself. You can chat, email, or call. At the end of this webinar, I want to thank everyone who attended and everyone who registered for this webinar. There is a small survey, really short, that will let me know how I did do throughout this webinar, whether you attended or receiving this recording in a follow-up email. You're still able to fill out the survey and let me know what you think. I wish all of you best of luck, and I'm here for you if you have any questions on this lesson. Have a good day.